going to be sick, all right, it has, that causes problems, all right, because again, you have to hear what I'm saying. That's why it's important if you're not here to try to listen to the video, all right. So again, I know there's a sickness going around, all right. So I need your attention today, especially the details here, especially the details, all right. And one of the most important things, which never made sense to me of why I have to write it, and the book always writes it, all right, is the very first thing. The very first thing says, segments that have the same measure are called congruent segments. Is everybody listening to me? All right. So if they have the same measure, that means they are what? That means they are congruent. All right. And what we're going to say is that is the definition of congruence. If they have an equal measure, then they are congruent. Is the converse true? If they are congruent, then they have the same measure. Is that true? Yes, 100%. All right. Now, I want to blow up something here a little bit for you. And I want you to really pay attention to this so you understand the difference. Equal versus congruent. Equal versus congruent. Lengths are what? Equal. Shapes are what? Congruent. We don't say that rectangle A is equal to rectangle B. All right? We say rectangle A is congruent. So when you're looking at shapes, we use the word what? Congruent. When we're referring to their measures, we refer to them as what? Equals. Is everybody hearing me on this? Everybody hearing me?
Yes.
All right. Now, again, down here, it is correct to say that AB is equal to CD. If something is equal, what are they referring to? The length, the measure. So, if you're referring to the length, do you need the symbol on top? No, because it's referring to a length. If you are talking about congruence, do you need the symbol at the top? Yes. All right. So again, congruence, it wants the symbol at the top. Now, honestly, do you think I'm that picky?
Yes.
I'm not that picky. I'm really not that picky. So if you accidentally put equals and you meant to say congruent, I might even overlook it. All right? But again, I need for you to understand the difference between equal and congruent. Equal is when you're referring to what? Equal is when you're referring to lengths. Congruence is when you're referring to the shapes. All right? Is everybody okay with that? All right, super important. It is not correct to say segment AB is equal to segment CD. Yes, sir?
When is our next test?
Probably Thursday, but I don't know why you're asking me that. All right? Now let's get back on track. Here we go. Now, congruent segments have the same measure. All right? Congruent symbol. There's your congruent symbol. All right? Now, I think yesterday we went through this. Does everybody agree? All right, I just reposted that because I think that's kind of important if you're looking through things. All right? Through any 2 points, there's exactly one line. Through any 3 non-collinear points, there's exactly one plane. A line contains at least 2 points. A plane contains at least 3 non-collinear points. And if 2 points lie in a plane, then the entire line containing those points lies in the plane. All right, next important thing here. If 2 lines intersect, their intersection is 1 point. And if 2 planes intersect, their intersection is a line. All right, we already talked about that yesterday, but I just wanted to highlight that just in case you're looking through your notes or whatever. And this is the most important thing. All right, now, second super important thing for the day are all the properties. All right, very, very easy, but I want to review them with you. All right, the addition property of equality says if A equals B and we add the same thing, they're still what? They're still equal. Is everybody looking at that? Please, don't just say that makes sense. Notice how they're starting out. A equals B. Then they what? Added C to both sides. That's why you're allowed to do that when you're solving equations. Now we also have the what? The subtraction property of equality, and the multiplication property of equality, and the division property of equality. What does this mean right here? C can't equal 0. Why is that necessary? C cannot equal 0. Somebody tell me.
You can't divide by 0.
Yes, you cannot divide by 0. You cannot divide by 0. All right, so now double check that because that's on some of your SAT tests. They'll have something and they'll put off to the side, C cannot equal 0. And then kids are like, well, why do they do that? Or because they're just simply telling you that the variable that's in the denominator can't be 0. Is everybody okay with that? So this is important. All right? Now again, I'm stating the obvious, correct?
Yes.
And that's what I always used to tell my geometry teacher. Come on, that's obvious. Do I have to write that? That's obvious. That's obvious. All right? Does A always equal A?
Yes.
Yes.
Yeah.
All right? If A equals B, does B equal A?
Yeah.
Yeah, there's a symmetric property of equality. Now, the transitive property. If A equals B and B equals C, then A equals C. So you understand that property. All right, now the substitution property is confused a lot of times with the transitive property. It just simply says if A equals B, then A can be replaced by B in any equation or expression. All right? And we're going to talk, we always do the substitution property, so I know it's not a big deal. And then, of course, everybody knows the distributive property. All right? Now, again, those are just the properties that allow you to perform your math. Does everybody understand that? All right? Now, I skipped the section where we had to write out every single step. Right? And you have to explain why you were allowed to add 3 to both sides. You're allowed to add 3 because there's an addition property that allows you to do that. You're allowed to subtract 5 because there's a subtraction property that allows you to do that. Is everybody with me? All right, super easy. All right, but again, the properties are extremely important for your proofs. All right? Now, segments. Do you think segments are equal to themselves?
No.
Yeah, right? So AB, segment AB is always equal to what? Segment AB.
Oh.
All right? And so again, the reflexive, the transitive, and the symmetric properties for segments and angles are just like the symmetric property of equality. So again, the numbers, the segments, and the angles all have the same properties. Is everybody with me on this? That's all they're saying. So there's a reflexive property for segments, a reflexive property for numbers, and a reflexive property for angles. Again, do we agree? Obvious. Angle A is always equal to itself. All right? Now, something I'm not really going to use with you, all right, but I want to tell you how it helped me out. All right? For the longest time, I could argue math inconsistencies. All right? So I want to look at the ruler postulate. All right? So the ruler postulate says on the ruler, all right, there's one point that corresponds to every what? Measure. Exactly correct. Everybody with me on that? Does that make sense? All right. Now I want to ask you a question because here's what I used to argue with my math teacher all the time. Once I figured out the square root of 2 was 1.414 ... What does that mean? It just continues. I asked him all the time, I would argue constantly, if 1.414 ... doesn't end, show me where it is on the ruler. That doesn't make any sense to me. Does everybody agree with me? Is everybody hearing me, right? That doesn't make any sense, right? Just like if I did a square that's 1 by 1 by 1 by 1, and I draw the diagonal. That diagonal is exactly what? The square root of 2. Thank you very much. That diagonal is exactly the square root of 2, because we know the Pythagorean Theorem is a squared plus b squared equals c squared. Agreed?
Yes.
And then I used to tell them, well, how do I measure the square root of 2? If I measure this thing to be exactly 1, and this to be exactly 1, and I can tell you that's exactly the square root of 2, but yet I can't figure out when the square root of 2 terminates. That didn't make sense to me. Everybody agree? That's kind of weird, right? So then finally I got to a professor in college who finally made it make sense to me. Because again, my mind does not accept it as true, but my understanding of math allows me to accept it as true. And that's what we're trying to ask you in geometry. Some things you just have to what?
Accept.
Some things you just have to accept are true, based off of observation. All right? Based off observation. So how did he finally convince me that the square root of 2 is on that ruler somewhere? Because I know that the square root of 2 is in between the square root of 1 and what? The square root of 4. Does everybody agree with that? I know that the square root of 3 is in between the square root of 1 and the square root of 4. Does everybody agree with that? That makes perfectly good sense. Agreed? And I know the square root of 1 is what? 1. And I know the square root of 4 is? Therefore, the square root of 2 must be somewhere between what? 1 and 2. Is everybody with me on that? Although I can't figure out exactly where it ends, I know it's somewhere between 1 and 2. Same thing with pi. With a little help from calculus, they were able to figure out what pi is, approximately. All right? I know pi fits somewhere on that ruler, right? Because it's 3.14 approximately. Agreed? So that's simply what the ruler postulate is saying. All right? Probably not going to use it that much, but it's something very important. All right? Now, scrolling forward, and again, to listen is much more important. To listen is much more important than trying to work. All right? So here we go. If D is in the interior of angle ABC, so I'm going to draw angle ABC. Here's B, here's A, and here's C. D is somewhere on the interior. If I were to draw that ray and call that point D. Now, why is this again called an angle addition postulate? Why is it called a postulate?
Because we have to accept that it's
We have to accept that it's true. I would say that's common sense, right? So what is that saying? That's saying the angle addition postulate is simply saying angle ABD plus angle DBC is equal to angle ABC. Everybody agree with that? I used to call it the parts equal the what? The whole. The sum of the parts is equal to the whole. Everybody agree with that? All right. So again, that's called the angle addition postulate. There's probably one for segments also, right? The segment addition postulate. So if you break down a segment, the sum of the what? Parts is equal to the whole. All right, so one we'll be talking a lot about is the angle addition postulate and the segment addition postulate. Everybody good on this? All right, something that we have to accept as true. All right? So now, did I give this whole thing to you right here, all filled out? Those are the answers, correct? I can't remember.
Yeah, you
can On
don't
your-
have it filled out.
Yeah, you don't have it filled out. Okay. So on mine, I just kind of eliminated that. All right, so here's your first proof. And really, I was going through this trying to make it really good for you guys. So what I did was I crossed this out. Oh, well, wait a minute. All right, now I'm back to where you guys are, sorry. All right, so we're going to talk about our first proof now. Or we're going to kind of prove this. All right, so let's give this shape here. All right, now you're going to read something. It says, prove, all right, that if CE is congruent to FE. So on your paper now, here's where we're going to start, right here. Now listen, this is the important part of the information, or important part of the day. All right, so I really want you to be able to mark your shape. So it says CE is congruent to FE. So I'm going to mark CE congruent to FE. Now notice I'm using one tick mark, correct? To show that those are equal. And then it says that ED is congruent to EG. So how many tick marks are going to use this time? So I'm going to prove that is equal to that. Now I have to prove that CD is congruent to FG. Now, would everybody agree I'm stating the obvious, correct?
Yes.
Now, let me show you why. Let's say if I said this length was 2, and that's 2, and that's 5, and that's 5. Does everybody agree? 7 equals 7. So that's kind of stating the obvious. But for whatever reason, kids have a really hard time doing this. All right? I just don't think it's that difficult. All right, but the first time it's going to be a little awkward, so you got to walk me, or you got to let me walk you through it. So please look up. So why is CE congruent to FE, and why is ED congruent to EG? Generally, the first, well, not generally, always the first part of the proof is the given. How do I know that's true? Because the statement what? Tells me that's true. It's given as true. If something is given as true, then you can accept it as what?
True.
As true. So for step 1, I want everybody to write down given.
Given.
All right, that is given. I'm walking you through your first step. First proof. Pretty soon you'll be able to do a whole proof. There won't be any statements or any reasons. You're going to have to do it all on your own. All right? Now, if CE is congruent to FE and ED is congruent to EG, then why does CE equal FE and ED equal EG? Why is that? If something is congruent, then the sides are what? Equal. Why was that? Because they are congruent. Exactly. So how do I represent that? We represent that by saying definition of congruence. Now, of course, I'm not asking you to write all that out, guys. Definition of congruence. We're going to do shorthand, or as much as possible. So I agree with that?
Yes.
Now, I want everybody to look at 3. CE plus ED equals CD. Why is that? What was it? It wasn't the angle addition postulate. Right. Again, the parts are equal to the whole. So again, that's called the what? Segment addition postulate. All right? That's the segment addition postulate. Now, for us, there's only one abbreviation for this, segment addition postulate. You might have to write it out several times. All right? But again, I don't mind because there's nothing else that will be abbreviated. Segment addition postulate. All right? Now, why does FE plus EG equal FG? What?
Segment addition.
Good job. Exactly correct. Again, same reason. Uh-oh. Hold on a second. Well, listen, FE plus EG. Now, you know what? I misread that. Did everybody see what I just did? All right. So look, I want to show something, which is obviously a mistake is never good, but in this case, we'll show you why I made the mistake. I knew that FE plus EG is equal to what? FG. But that's not what they said, correct? They said what?
Plus EG.
Now, why is that? Now, here's what I'm trying to show you now, guys, so please pay attention.
Because CD is equal to FG.
That is a CE is equal to what? FE, and ED is equal to what?
EG.
So please watch now up here, all right? Again, I don't think this is that hard, but every year 2 or 3 kids, just for whatever reason, don't pay attention initially and then they miss it. So I'm trying to tell you, please don't miss it. Right now, don't miss. Right? Look at this step right here. Right up here, it says CE is equal to FE, right? So where I see a CE, I changed it to what? FE. Did everybody see that? And then I want to show you up here that ED is equal to EG, right? So wherever I see an ED, I changed it to what? I changed it to EG. Is everybody with me? And why are we allowed to do that? Because we can do what? Substitute. Right? It's called the substitution property. The substitution property. Is everybody okay with that?
Yes, sir.
Any questions or concerns right off the bat? All right, I appreciate it. All right. Now, the next step. We have to look carefully because I didn't look carefully and I made a mistake. The next step says that FE plus EG equals FG. So we just did it what? We did it out of order. You with me? So now, some of you are going to ask me this question. You got to hear me. If your proof is logical, does it matter what step you did? You might be thinking a little bit different than me, so your order might be a little bit different. Do you agree? Does that make you wrong? No. As long as that's why it takes me sometimes longer to grade your test when I have proofs, because I got to figure out how you're seeing things. Is everybody with me? Personally, I think it's easier to do my own proofs than do these proofs, because I see things differently than what they did. All right? Does everybody see that so far now? Right? Now, here's the hard part. I want someone to try to think about it. Why is CD equal to FG? Why is CD equal to FG? Go ahead, I want you to tell me. Yay, very good, very good. Now again, listen to me. I'm not thinking that's hard, but some kids, for whatever reason, find that hard. So what I'm telling you is you kind of have to look at the step ahead to figure out what the next step is. And how did I know CD was equal to FG? Because now the key is right here. I'm going to try to highlight this so you can see it real nice. This right here. Does everybody see what I'm highlighting? Those are the same. Does everybody agree? And they're equal. Does everybody agree with that? So again, it's just a what?
Substitution.
It's a substitution. Do you agree? Now, I have them as equal, but they want them as what? They want them as congruent. Now, sometimes you're going to forget that on the test. Do I really care? No, I don't really care. I just want to be formal. Does everybody agree with me?
Yes.
So you technically should go ahead and say what? That CD is congruent to FG by the what?
Definition.
By the definition of congruent. Because we're talking about things that are congruent, not things that are what? Equal. And when you're adding things together, you're adding segments, which means you must be talking about a length, which means you must be talking about equals. So right here, what I just said.
Yes.
Congruence has to do with comparing the shape. Segment addition postulate has to do with comparing the lengths. So you have to have everything what? Equal. Congruence, all right, has to be when you're referring to the shape. All right, hopefully you're making sense with this. All right, so now let's take a look here at the next one. All right, here we go. Now I'm going to mark the figure. I'm going to mark JL. Stay with me. JL is congruent to KM. And I mark it like that because I can't do the overlap. Is everybody with me? And I am trying to prove that JK is congruent to LM. Now again, I would probably say that's stating the what? That's stating obvious, but we're going to prove it. Now again, I'm telling you, listen, this is hard for some kids, right? But as soon as you see it, you'll go, wow, that's super easy. All right? But you got to see it first, or you just, writing in my answers is not helping. Writing in the answers is not helping. All right? So here we go. JL is congruent to KM because? Given. Why is JL equal to KM? Definition of congruent. Thank you very much. JK plus KL is equal to what? JK plus KL is equal to what, please? JL. Now, the minute you don't know something, tell me. KL plus LM is equal to KM. Anybody have an issue with that? That is called the what? Segment addition postulate. Now, why in the world are those two things equal? That is right, substitution. Now, some people don't see that, so I'm really trying to do a good job this year of showing you exactly why that's true. Now, I want everybody to look right here, please. I'm highlighting JL. I'm replacing JL with what? With what? Whoa, 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 whoa. Wrong, wrong, wrong. That's what I'm saying. I'm glad I'm doing this. I'm glad I'm doing this. Eyes up, eyes up, eyes up. You see this statement right here, guys. Statement B. You're seeing statement B. You see this JL right there.
Oh, I see.
I'm replacing JL with what? JK plus KL. I'm then replacing KM with what? Do you see that now better? Right, I'm looking at part B. I'm looking at part B and I'm replacing JL with this. And then I'm replacing KM with what KM is equal to. Does everybody agree with that now?
Yes.
All right. Now, I would disagree with them on this a little bit here. Right? How do I get that? And again, I want you to put a parentheses around this. All right, I want you to put a parentheses around this because this is not how I do it. Right? I'm looking at section or step D, and now from D, I'm going to F. I'm skipping E. Why is JK equal to LM? Why is JK equal to LM? What did I do? Yes, that's the subtraction property of equality. All right? What they're talking about is substituting KL minus KL is what? 0. So that's what they're talking about there. We're not doing that. Hear me? Everybody with me? If I'm at this step right here, if I'm at this step, we go directly to this step because what did I do to both sides? Subtracted what?
KL.
Subtracted KL from both sides. If I subtract KL from both sides, I get what? JK is equal to LM. That is the subtraction property of equality. Everybody happy with that explanation?
So F is the subtraction property.
Yes. All right, that's what I want you to put down. I really kind of want you to omit what? I really do not. I really do not like E at all. I really do not like E. Does everybody hear me?
Yes.
Right? And again, because JK is equal to LM, then JK is also what? Congruent by definition of congruent. Is everybody good on this? Yes.
So I don't understand why F is subtraction. Isn't that what E is, or we just completely get rid of
I can completely got it. You hear me? Because again, I'm trying to make it make sense for you. right? If I'm at this step, and I go to this step, what did I do to get from this step to this step? That's why it's subtraction property. You with me on this? They want you to take KL minus KL, and what's KL minus KL? 0. They want you to, I mean, we're not doing that. All right, well, that's just not necessary. Okay? Of course. All right. So you're doing good today, I think.
How would you get from D if there's nothing in that? Like, how do you?
What do you mean there's nothing?
Like, it has the question mark before you do anything.
Right.
How
So
do you think
to
of
get from D to F, I just subtracted KL from both sides.
it? Okay.
So this statement right here should be, in my opinion, this, if I was writing the solutions, this would be the subtraction property of equality. You agree with that?
Yeah.
All right, that's how we're going to do it.
Okay.
All right. Now I'm just going to continue to scroll up a little bit. All right. Now I just really want everybody to just get an idea of what a paragraph proof is, and we're never going to do that. I'm never going to ask you to write the proof. You're always going to write a 2-column statement, but I just want to give you a sample of what they ask. All right. It says AB is congruent to CD, so I'm going to mark that. And then CD is congruent to EF. Well, that would have one tick mark too, right? Therefore, AB has to be equal to EF. Is everybody with me? So now instead of making a formal statement and reason, they just want you to talk your way through it, which isn't bad, but not something we would do. All right, so what does it say? Since AB is congruent to CD and CD is congruent to EF, AB equals CD and CD equals EF by definition of congruent segments. By the transitive property of equality, AB is equal to EF. Does everybody agree with that?
Yes.
That's the transitive property. You could also say what property though? Substitution. You agree? All right. So if AB is equal to F, then AB must be what? Congruent to EF by definition of congruence. So again, kind of silly. But now, listen, the people in geometry were just trying to formalize everything. All right, you weren't allowed to just say something is true. You had to what? Explain why it's true. You had to prove everything. All right, you have to prove everything. When you get to higher level math, there is a proof for everything. All right, there's a proof for everything. All right. Now, did you guys have? Did I wipe this out, or did you guys? Did I wipe that out on yours?
Yeah.
All right. So let me wipe this out on mine again, and you guys can kind of. We have some time. Let's go ahead. I mean, I'm not going to wipe that out because I think you guys know now. All right. So here we have. All right. Again, it should be kind of easy. The first step is generally the what? The given. All right. So let's mark the given. It says X is the midpoint of SY, and Z is the midpoint of YF, and XY is equal to YZ. I want to prove that ZF is congruent to SX. Come on now. I think it's very simple, but can be kind of confusing when you're first starting out. Or does everybody agree with the given?
Yes.
Now, can somebody please tell me why SX is congruent to XY? Why is SX congruent to XY? Tell me. Yes, exactly. Now, in other words, simply by defining the midpoint, we know that's true. Does everybody hear me?
Yes.
So we would write as our reason, what do you think? Definition of midpoint. We would write definition of midpoint. Everybody agreeing with that? All right. So now xy is congruent to yz. Why is that? I think it's definition of congruence. Now, because y, look right here, and it's okay to miss that, because they simply say right off the bat that xy is congruent to y, or is equal to yz. And if it's equal, that automatically means it's also what? Congruent. It's automatically congruent. Now, again, I'm just trying to tell you from my own personal experience, would I miss that sometimes? Yes. You have to be careful. They don't want you to interchange the words equal and congruence. Do I do that all the time? Yes, because I just know it's true. So why would I waste an extra second writing it out? Does everybody agree with it? All right, but when you have these right here, they're already worked out for you. All right? So now that we have that, the next step is why is xx congruent to yz? What property is that? Nathan? I would say substitution is good. We could also probably say, you could also say transitive. Would I ever mark you wrong if you wrote transitive property rather than what? Substitution. No. All right? Substitution is replacing one for another. Transitive property is technically when you're saying two things are equal to the same thing, then those two things are equal. You with me on this? And that's essentially what that's saying. But I can also see your point, well, I just replaced one with the other. So I'm not arguing with you on the transitive property ever. Most of the time I would write what? Substitution. What?
How is that substitution?
Okay, so look right here. You got to follow the flow. It's very, very important. See this right here? Sx is congruent to xy, right? Yeah. Xy is congruent to yz. So yz and sx are congruent to the same thing. Therefore, they are congruent.
Oh.
Did I see that right?
Yeah.
Right? Very important. Like I said, you're not alone sitting there if you're going, I'm not sure. And sometimes I have to point things out. And if you point them out, it's easier than trying to flip through all this on your own. All right? So now, why is xx congruent to zf? We can do that again, right?
Yeah.
Because yz is congruent to what?
CZF.
So I can replace yz with zf. So we could do this substitution. We could also call that the what?
Transitive.
We could also probably call that the transitive property. Yes, sir.
Why would 4 be transitive?
I showed you. Transitive is if two things are equal to the same thing. Sx is equal to xy, and xy is equal to yz. Transitive property says that those two have to be equal.
Okay, I see.
You with me? All right. Everybody's happy with that? And then your final step is to say, why is zf congruent to sx?
Definition.
See, I would leave this part out also. I would totally leave this out. But this is where I'm trying to show you now. They're just being completely formal. Is everybody hearing me? They're being completely formal. Listen to what I'm saying. Look up here. They want what? ZF congruent to SX. Right now I have what? So it's out of order. So why can't I just flip the order? What property says I can just flip the order? There you go, kiddo. Beautiful work. When you switch the order, it's just the what? Symmetric property of congruence. Would I expect you to write that out? I would probably not write that myself, to be perfectly honest. In my mind, I would just write it the way they want me to write it in the proof. Is everybody with me?
Yes.
All right, but I'm just trying to show you now. That is the absolute formal proof for that in full detail. All right, that's the absolute correct answer. Other than the fact that instead of transitive, we could have put what? Substitution property of equality. Is everybody with me on this?
Yeah, I understand.
All right. So again, not bad. Not bad at all. Let's continue on. What time is the bell ring, guys?
45.
What time is it?
42.
Okay. So here's what I want you to do, guys. I kind of would like for you to just kind of, again, go through, because we got to have another day on Monday to do this. And then Tuesday and Wednesday we're reviewing. So there's a lot going on. There's a lot of proofs here. I need you guys to review the properties. Come on, stay with me. Look up. I want you to review the properties of angle congruence. Then symmetric property of congruence was just read what it says down there. That'll help you.
We don't have that.
Okay, I'm not sure why. But now, here is where we start doing, is that a little bit different now from you guys?
Yeah, we don't have
Yeah, okay, so I'm going to do this now. Here's what I did.
We have this.
Shh, hold on. I'm back with you now. So what I was doing was I cut this up, so I think it makes better sense than the way the book did it. All right? So I'm going to, this is where you're at, right? I put read there. I put the solution here for you. All right? Then we're on properties of congruence. You with me? Which we already talked about. And now we're going to write the two-column proofs, right? So we're on this part right there. Does everybody agree? So now your job now is to start writing the two-column proofs if you can. All right? Now what I'm going to do is I got all the way to here when I was doing my proofs. And I have a little bit more to go. And then there's some problems down there. So listen, I'm going to post the answers. All right? But I need you to listen to me.